So in this little lesson, we're going to talk about a special conjecture for isosceles triangles. But what I definitely want to point out to you, though, is that we got to get a couple more definitions first. So the first one we're going to talk about is a median. So over here in this diagram of a triangle, you see a median. This is our median. So the question is, what's a median? So first of all, notice that a median is a segment. And it's a segment that is joining the vertex of a triangle. Okay, so it starts up here, starts at the vertex of the triangle. It joins that vertex. And the midpoint, can you tell how the triangle is marked? Look at these two markings here. That tells us that the other end point is a midpoint. And the midpoint of the opposite side. So based on our figure here, we're going to put this vertex, and it joins to the midpoint of the opposite side. So this is one median in a triangle. Notice that a triangle has three sides, so there's also three midpoints. I'll just kind of make up where I think those midpoints are going to be. I'll mark them appropriately. And if I was to draw in the other medians, there would be three total. So there are three medians to every triangle. The next definition we got to come up with is for an altitude. So likewise, in this triangle, this here is our altitude. Notice how the triangle is marked. What is an altitude? So an altitude is a perpendicular segment. Okay, it's a segment, but it's perpendicular. So what's it perpendicular to? Where does it come from? Well, it comes from the vertex of a triangle. And let's see, I'm missing all my words here. It goes from the vertex of a triangle to the opposite side. That's what we want to say. Apologize about that little hiccup. That's what an altitude is. And likewise, because we have three vertices of a triangle, we can draw in three altitudes of a triangle. Now, the interesting thing about the altitudes of a triangle, and I'm just going to reveal this little thing on the bottom, is that in some triangles, an altitude is inside the triangle. See this one on the left? The altitude is inside the triangle. Sometimes the altitude is outside the triangle, like in this one here. And that's where I want to kind of amend this definition, because what I had to do in this triangle here was I had to take this side, this base, and extend it to draw my altitude. So I'm going to say that it goes to the opposite side, or a line that contains the opposite side. I'm going to kind of amend that definition a little bit. And in some triangles, the altitude is one of the sides of the triangle. Pretty neat. Okay, let's keep rocking. So now we know some of these terms. Let's get investigating. We know what this thing means. Boom, check it out. So what you see here is an angle bisect, or you see a triangle. It's isosceles because of the two markings. I want to show you the angle bisector. So I bisected the vertex angle. Okay, remember, since side AB is congruent to AC, angle A is the vertex angle. And notice that I divided the angles into degree measures of 21.7. And if I drag my triangle around, please notice that the bisector remains true. Now the angles are 47.4 degrees. So I can move my angles around a lot. Well, I want to show you two other measurements as well. Boom. So the first measurement I want to show you up here is that the measure of angle CDA is 90 degrees. That's the angle I've marked in blue. It's a right angle. And watch, if I drag this angle or this triangle around, as I drag it, look at this angle measure. Does the angle measure change there? No, it doesn't. Interesting. So the angle bisector is another segment as well. Cool. Oh, but look at these two measurements down here. Check them out. Hey, they're equal to each other. And sure enough, if I move this triangle around a little bit, those measurements stay the same. Well, they don't stay the same, but they stay equal to each other. And that means that the angle bisector is a third segment as well. So let's get back to our lesson and check this out. Here's our conjecture. We're going to say in an isosceles triangle. So I'm going to start by drawing an isosceles triangle. Here's my isosceles triangle. And if I bisect the vertex angle, what other segments is that angle bisector? Yeah, so if you were telling me, let me clone this thing again, right? Let's see, let me clone it. Boom, slide it all over here. Great. There we go. So if I know it's an angle bisector, I also know it is an altitude of the triangle. And it's also a median. And what's nice about this relationship is that if you know one, you know the other two. What I mean by that is if you know you have an isosceles triangle and you know that a segment is a median, a segment drawn from the vertex angle is a median, it's also an altitude and it's also an angle bisector. If you draw the altitude from the vertex of an isosceles triangle, it is also a median and an angle bisector. All three of those go together. So if you know one, you know all three.